Hello, this is Mr. Jarrett, and in this video tutorial, we're going to be 3D modeling this object in SolidWorks. So the first thing that I always look at here are the units, and I can see that I am in mmgs. That is why I have a lot of solid numbers, no decimal places here. Second thing I want to look at is where my origin is. So I can see the origin is located on the top of this object, kind of right in the middle of this circle, which that circle is a through hole, so it goes all the way through. Then I'm kind of looking at it and seeing, all right, where do I start? What are the easy parts here that I can see? Well, the base of this kind of goes up and over. It looks like it's got some filleted corners, some circles on it, and it looks like it's pretty symmetrical, which it is. Okay, and in front of the origin and behind the origin, it looks like it is exactly symmetrical. And I can kind of see that over here by the center of mass. So my zero, I have 0 for x and I have 0 for the z as well. So it is symmetrical. It's just not symmetrical, obviously, on the y, up and down. So where to start? Most people would start up here on the circle and try to build your way down, and you could do that. I just noticed that you kind of run into problems as you do that. So I'm actually going to start on the front view, and I'm going to try to draw this base first, and I'm going to offset it by using these measurements. So let's go over to SolidWorks. Let's start a new part. And the first thing we want to do here in our part is we want to make sure that we are in MMGS. So let's switch over to MMGS if you're in IPS. And we're going to be sketching on the front plane. Now, because this is symmetrical, you can just kind of mirror one side over. So I'm just going to get my construction line, and I'm just going to draw down from my origin, something like that. Okay, I'll hit escape. Now I'm going to get my line tool, and I'll start way over here. And this is going to be the base of the part. So it comes over, it goes up, there's a little cutout in the middle, and then over to this piece. Okay, I'll hit escape, get my line tool again, and I'll just kind of complete this. So this goes up, over, up, and back over. Now there's a lot easier ways of doing that. You could offset it. You could have just drawn the whole entire thing. There's plenty of other ways. I'm drawing this in the way that most students would actually draw this. So going ahead and starting to dimension this, I can see from the very bottom of my entire part all the way up to my origin. So the largest measurement first here is 45. So that's that offset that I was talking about. Okay, and I didn't say this yet, but you saw when I was drawing with the line tool, I made sure every line was either horizontal or vertical lines because it's a pretty squared off object. So the next thing is it shows that from the bottom of this up to this cutout, that's basically the length of this line, is 14. The gap in here, so from here to here, is got to be half of the measurement we see in the picture, and the picture shows 20, so this is going to be 10 because I'm mirroring this over. So as you can see, that's this part right here. And then I see there's a 7 TYP, so that means typical. So this entire thickness is 7 all the way across. So go ahead and click this. Oops. And that's why I said if you wanted to use the offset tool, you could have because it's just a constant thickness of 7. So I'm just going through and putting in 7 for the spacing of each one of those. And then bringing my picture back over here, I can see the overall length of this from one side all the way to the opposite side is 92. But it also has another measurement here just from the outside to this inside is 36. So we could do the 92 divided by 2, but I think it's pretty easy if we just do this and make that 36. Okay, so that's now fully defined. So let's go ahead and mirror this over. Get my mirror entities. I'm going to basically select all that stuff, and the mirror about line is going to be my construction line. That should be fully defined. So now I'll go to the Features tab, and I'm going to hit Extrude. And because the origin is in the dead center of this all the way at the top, and it's symmetrical forward and backwards, I can change this from blind to midplane, and I can find the overall depth of this entire thing, which is pretty obvious. It's over here on the far right. It says it's 40. Okay, so I'll set this to 40. Hit the green check. And now there are holes in each one of these corners, but those corners are also rounding. So which one do you do first? I would recommend actually filleting the corners first, because later on when you try to put in those holes, you already have the center points. So I'm going to get my 3D fillet on the Features tab, and it shows in the bottom corner of our picture, it says 4x radius of 6. So 4x means it's 4 different times, so it's all 4 of these corners. Just carefully go through and click each one of the lines, and we can hit the green check. Now, you could make a sketch on here and put circles right on those and cut those out, and you could say, hey, the base is done. That's fine. But I know later on that I am going to be drawing a circle at the very top and cutting this down through. So when I'm sketching up there, I'm going to sketch all 4 of these circles as well from way up here at the top and just say through all. So it cuts down through. It just takes off one extra sketch that you have to do. So now that I have those done, let's try to start knocking out this middle piece. So I'm going to be sketching up here at the top where my origin is. And you could do this multiple different ways, but again, I'm trying to model this in a way that students would understand. So drawing it up from the top, I'm going to draw this outside tube first, and that has a diameter of 36. And yes, you could put other things all in that sketch, but I'm just going to make it simple here so that we can follow along. So I'm going to sketch, but this time I want to sketch up on the top plane. So not the top of the part, the top plane. So that's way up here. Okay, I'm going to get my circle tool. I'll draw off of the origin, and I'm going to dimension this to 36. So you can see it hangs out past just a little bit here. Now when I hit extrude, we don't want this midplane. We want to change this back to blind, and we want to send this down towards our part. Now here's the thing that a lot of students might miss. A lot of you might just do this and then draw a rectangle and cut that off. If you change this from blind to up to next, it's going to go down until it hits something. And this goes all the way down to the surface. So you can see it saves me from having to cut out the stuff in the middle. So I'm going to hit the green check. Okay. Now I'm going to sketch back up on top here. And I'm going to neck this thing down or trim it down. You can kind of see on this that there's a little lip right here. So I'm going to draw another circle, that's 30. And I'm going to cut off the remainder here, that between the 30 and the 36. And like I said, there's other ways of doing this. But I'm going to draw a circle. I'm going to dimension this. Okay, that's going to be the 30. Okay, and we'll draw another circle here that's going to be matching to the outside piece. Okay. Now, even though I clicked on that, mine did not lock in, so you might have to either dimension it or you can drag this out. You might be able to drag it back in and it might lock. Other versions of SOLIDWORKS, it has locked before. So you could define that thing just by making them co-radial, but it's pretty easy just to make it 36 so that you don't miss anything here. Okay, so now it's the exact same size, so I have a closed-in area there. Now I'm going to use the cut extrude, and I'm going to cut some of that down. So how far down does that go? Well, this is where we have to do a little bit of simple math. So from the very top all the way down to the bottom is 45, but from this lip down is 30. So the difference between those two is 15. Okay, so I want to cut this down 15. All right, now that kind of gives us that top part. Now I can do my holes. So let's sketch back up on top again. And I'll say this probably for the 4th time now. If I were doing this by myself, I could have done this a lot more efficiently with a lot less sketches if you know what you're doing as far as like offset extrusions and things like that. I'm going to draw the inside, and then I'm going to move my mouse out here, just pause on that fillet, and there comes my center point. Do the same thing here. Yes, you can mirror this over, but it's going to be just as fast to draw all 4 of these. Okay, the outside 4 circles, so those 2, hold in shift, and these 2, they are all equal to one another in size. We can dimension one of them, and it shows us on the picture that it says 4x, and these have a diameter of 6. The inside hole, it says, has a diameter of 20, and it says through, meaning it goes through the whole thing. Okay, and yeah, I'm floating way up here, but that's okay, because when I go to the cut, it's going to be down and it's going to be through all. So it's going to go all the way down and through all. That just saved me a sketch. So now I got my holes. So this is almost done. Now is the tricky part of this, and it's really not that hard. But this is kind of a gusset or a corner piece in here for support, and this is called a rib. So you can use the rib tool for this. So this can be rather difficult at times, especially because this is on a curved surface. Okay, so some students would try to draw like a triangle and extrude, and you'd notice that you'd have a gap here because it's a curved surface. So by using the rib tool, it's going to fill in around that entire curve. That's kind of also why I have this one in my curriculum. In order to do that, we want to draw right in the middle. So if you think back to the first extrusion, that was drawn on the front plane. That's in the middle of this entire part, as you can see. So I'm going to sketch on that front plane again. And you're going to just draw one rib at a time, and you can mirror this across then. It doesn't let you do both for some reason. So I'm going to get my line tool, and I'm just going to click on this line and then down here. Now you want to be careful when you're moving down to this line that you don't click on that midpoint, you don't click on this point. I know sometimes the center point pops up of the circle, there it is. You just want to be on that line itself. Okay. And then if you look at the drawing, it says it's 18 by 18. So this is a triangle. So even though that corner is rounded, we're going to do that later. It's 18 in its base, it's 18 in its height. It's not measuring the hypotenuse. So get your smart dimension tool, and if you just click on the angled line and pull straight down or straight up, doesn't matter. This is going to be 18 wide. If we do the same thing again, if you pull over to the right or the left, we're going to make this 18 tall. So that's measuring from that dot to that dot in vertical is 18. That dot to that dot in horizontal measurement is 18. Now that's all you need to do. You don't need to close this in because the rib tool is programmed to do that. So we're going to get off of the dimension tool, go over to the features tab and hit rib. And if I rotate my screen so you can see what's happening, it recognizes that I just drew a single line and it wants to know what the width here is. So on the picture, it says the width is 4. So when I make that 4 and I have this middle selected, which is the default for this, you can go on one side or the other side. The middle, it's going to fill in down to my part. So when I hit the green check, you're going to see it fills everything in. The nice thing with the rib tool is it filled in all the way around that curve. If you were to draw a triangle and try to extrude mid-plane, you'd have a gap right here because it would not compensate around the curve. Now, could you draw the triangle inside of the part? Yes, but then you would also have to draw an extra little line here and calculate where that point cuts into the cylinder. So this is the easiest way. This is the rib tool working on that cylinder. Now I'm going to mirror this over to the other side because I don't feel like drawing another sketch. So when I do the mirror tool, it's going to ask me my face or plane. Well, remember the origin's right here. So we've already drawn on the top up here, we've drawn on the right. If I hit this drop down, there's we've drawn on the front and the top. We're going to use the right plane that cuts through it this way. And the features to mirror is going to be my rib. It's going to mirror that entire thing over. Green check. Okay, last thing that we need to do here before changing our material is just add in these fillets. And if you're looking at the measurement for these fillets, it's kind of hard to find. But there's one little measurement up here that says radius of 3 TYP. So that means this edge, down here where it also connects, and it's going to be the same thing on the opposite side as well. So we're going to be on our Features tab and get our fillet tool. And this is going to be a radius of 3. We'll just click on that top edge, And yes, you could have done this first and then mirrored over with the rib tool. I'm going to hit the green check. Now let's change our material. I believe it's brass. Change it to brass. We can check our mass properties. Pull this back up to see how we did. So we should be getting 375.43 grams. If you got that, you can save this and move on to the next one. If you didn't, keep on problem solving until you get it.